Good day to all of you. So we're already in chapter 13, all about file system interface. So file system interface, this is another feature that makes the different OSs different with each other. So to know more about the file system interface, so let's start this lesson. So again, chapter 13 is all about file system interface. So the contents of this chapter is all about file concept, access methods, disk and directory structure, file system mounting, file sharing, and protection. So the objectives of this chapter are to explain the function of file systems, to describe the interfaces to file systems, to discuss file system design trade-offs, including access methods, file sharing, file locking, and directory structures, and then to explore file system protection. So let's go around with file concept. So a file is a contiguous logical address space. As I've already discussed, for example, if you have a video file that is stored in your disk, for us users, we see that as a one, for example, your movie is 1 gig. You see that file as one chunk of 1 gig file of a movie file. But inside the storage or in our disk, in our hard drives, actually, if this video file is already, for example, stored in your hard drive for a year ago, it is possible that this 1 gig file, its parts are scattered scattered. It's not in one place in a hard drive. If, example, you're not performing defragmentation process. Okay, so that is the idea here, that the file, for us, we see it as one file, as but if it's a large file, there is a possibility that its parts are scattered in all the spaces in the hard drive. It is up to the operating system that if you're going to, for example, open that file, the operating system knows where are these parts of the file. So that's why, as I told you in the previous lessons, in our previous chapters, that it's very important to do the fragmentation process because it makes the loading of the file easier. Because if your file is if your hard drive is not going that defragmentation process, for example, for that video file, the operating system is very doing itself rigorously to locate all the parts of the file. So again, so for easier loading of your files, specifically large files, you must do the defragmentation of disks. Okay, so next is we have types. So files actually has many types. It can be data. So data can be numeric, character, or binary, or it can also be a program. And then the contents defined by the file's creator. Specifically, if you are using Office Productivity Suite, so you're the ones who's control what will be the contents of your document, of your Excel file, or of your slide presentation file. And file, of course, has many types. So this is an example. So consider a text file, a source file, an executable file. So later on this slide presentation, there is a table of the general classifications of file types. Okay, next is we have file attributes. So the common file attributes are, we have the name, only information kept in human readable form. Of course, this name is also called the file name. And for files that the user is creating, so it's also the user's discretion of what will be the name of the file. But of course, for system files, for operating system files, so of course it is done by the system. But for files that is solely created by the user, it is the user's discretion of what he or she will be the name of the file. Next is we have the identifier. It is a unique tag or number that identifies file within the file system. And then next is we have the type. needed for systems that support different types. So for type, it can be identified, of course, by using the file name extension. So if it is a docx, it's a word processor file. And then if it is, for example, a pptx, so it is specifically a Microsoft PowerPoint slide presentation file. And then next is we have the location, so pointer to location to file location on device. And then of course the size is the current file size. And then next is we have the protection, controls who can do reading, writing, and executing. And then time, date, and user identification, so data for protection, security, and usage monitoring. So information about files are kept in the directory structure, which is maintained on the disk. It has a separate space for the directory structure has a separate space in the disk. And then it has many variations, including extended file attributes such as file checksum, so that if there is a error in the file, and then information kept in the directory structure. So this is an example of a file information window on Mac OS X. Of course, Windows has its own. So let's have an example here. So let's open, okay, our subjects folder for an example. Okay, just please wait for my very fast computer to load the folder. Okay, so for example, let's open the, how are we going to know the file attributes? Actually, it is in, we're going to right click. Okay, let's wait again to load even the context menu. Okay, so we have here the properties. So this one, so with the properties, so in general, of course, this is the file name. Actually, because it's a text box, you can edit here the name of your file. And then, of course, it is also included here the type of file. So it's an Adobe Acrobat document or PDF portable document file, and opens with of course Adobe Acrobat Reader, but actually you can change it if you want to. And then the location in the folder, and then the size, and then the size on disk. So there is difference with the size and then the size on the disk. And then also here we have the created, when it was created, when it was modified, and of course since we accessed it today, even the property. So for security purposes, so it has a log that the latest that it was accessed 1 minute ago. So if you want to know more the details of the file attributes, so we have here, so it's almost here, but there are also different um, files that has longer details. So for PDF, it's also just the same as with general. So actually, it depends upon the file that you're going to look for the properties. Because there are, for example, let's look with other properties. Okay, so a slideshow presentation. So let's see. Okay, let's wait for it to load again. Okay, so this is the general, just as the same, since it's like this general is the summary, and then these are the details. So as you can see, for slideshow presentation, there are authors, and then last saved by, and then how many revisions does this slideshow presentation has undergone, and then of course the program name for it to open, and then the company who produced this slideshow presentation, as I've already mentioned in the first slide, that I don't own this. So, and then it was created 2004, and then it was last saved um last April 3, 2021. So, and also the editing time. So again, it depends upon as I've told you, it depends upon the file type, because these are the other details of the file. Okay. Okay, so we're already finished with that. So Mac OS has their own versions, and of course, Windows has also its own version. Okay, next is we have file operations. So file is an abstract data type, and then these are the common operations that is done or in a file. Commonly, file operations that is general to all files. So of course, we have create. So you know how to create a file, a new document, a new slideshow presentation, a new Excel file. And then next is we have write at write pointer location. And then specifically write and read is if the file is loaded in memory, and then read is at read pointer location, and then reposition within file is we're going to use the seek, and then also with reposition within the file is loaded in memory, and of course we can delete a file. Okay, we can delete user files. Actually, we can delete also system files, but we have to be careful because specifically files that is in drive C, because if you're going to delete that and you don't know the consequences, so better safe than sorry, do not delete it. But of course, you can delete the user created files. And then what is truncate? So the user may want to erase the contents of a file but keep its attributes. And then we also have this file operations open, and then the parameter is f sub I or any file that is existing. So search the directory structure on disk for entry f sub I and move the content of entry to memory. You can imagine open such as, example, you're going to open a file, you're going to click the icon of that file. So by clicking that, you are invoking the function open, and then the parameter is the file that you have clicked. And of course, we have close. We can only invoke the close system call or function if the file is open, of course. You cannot close if there's nothing to close, of course. So we have this one, move the content of entry f sub I in memory to directory structure on disk. So it's like, for example, you're doing your file, and then if you want to save and exit or close, so clicking the exit or the close button, that will invoke the command close. And then of course, the file that you are closing, of course. So these are the common file operations. Okay, next is we have open files. So several pieces of data are needed to manage open files. So for open files, there is an open file table which tracks open files, of course. And then we also have file pointer, pointer to last read or write location per process that has the file open. And then we also have the file open count, counter of number of times a file is open to allow removal of data from open file table when last processes closes it. And then disk location of the file, cache of data access information, and then access rights per process access mode information. So we will be dealing with the access rights. And then of course the disk location, as you can already see with the properties, we have already the path name where the file is located. So how about this file open count? Okay, so let's illustrate a file open count. Okay, again, let's go back with our folder, with our subject folder. Again, with our assignment, we're going to open it in, of course, the default program. So let's wait to load the context menu. Sorry for the lag. Okay, so let's open it, of course, by the default program, the Adobe Acrobat Reader. And then the other one, so we've already, you already are familiar with this assignment, if you are. And then next is let's open it with, let's open it with a browser. Okay, again, sorry for the lag. Okay, let's wait for it to respond. Okay, this is already open, and then we just need to wait for my ever fast computer. Okay, we're still waiting. Okay, thank you. Okay, so let's open it with Microsoft Edge. Okay, we can possibly open one file in with two different applications. So first is we open it in the default, which is the Adobe Acrobat Reader, and we can also open it in a browser. As you can see, they are just the same files. So for example, if you're going to edit anything, because you can actually edit a PDF now, in, for example, this in Adobe Acrobat Reader. So actually, if you open this file in two different applications, so the mode is in read-only mode. So if you're going to edit this, you will be warned that you have to close the other applications that has this another instance of the file opened, because you're going to edit it. So there is actually a discussion in the presentation that for you to edit a file, it must be exclusively open to one application only. Actually, this can be open in any other application that is, of course, applicable with a certain file type. So for this mode, so since even though this is a portable document file, um, these are all in read only mode. You can open concurrent copies of that in read only mode without any modification or editing of the file. So what am I illustrating here is the file open count. So in our system, in this computer system, so we can see here that this file, this file is we have it's a specific file. The name is CPT221 assignment 7, is opened in two different applications. So we have the file open count. Okay, so we can close it now because I've already shown you that it is possible to open the same file with different applications, as long as the application is correct, correct. It can really open that particular file type. Okay, next is we have Okay, next is we have open file locking. So provided by some operating systems and file systems. So it is similar to reader-writer locks. So we have a shared lock similar to reader lock. Several processes can acquire concurrently. This is what I'm saying when I opened that same file in two different applications, that those application, they have shared lock, because of course your purpose is just to read, is just to view the file. But if you want to edit it, so it will have an exclusive lock similar to writer lock. So for example, if you really want to edit, there will be a warning that you have to close all the other instances of the file for the changes to be in effect. Okay, next is mediates access to a file, the open file locking. It can be mandatory or advisory. So for mandatory, access is denied depending on locks held and requested. And then we have advisory, processes can find status of locks and decide what to do. Okay, so for this code, So a file locking example by using the Java API. So this illustrates file locking in Java. This program acquires two locks on the file.txt. So this first half, so the lock for the first half of the file is an exclusive lock. And then for the second half of the file is a shared lock. So as you can see, we have this shared lock. Okay, so next is we have a table for file types, their names and then extension. So these are the general file types existing in a computer system. So we have first the executable. So the usual extension is the .exe. So of course executable exe. Then .com command. Then .bin is binary, or it can be there is a file that has no extension at all. But for Windows, it comes with exe, com, and bin. Maybe for none. These are for other operating systems. So the function of executable is ready to run machine language program. And then next is we have the object. We have the .obj and then the .o. So these are the compiled machine language not linked. So .obj is produced, for example, in Turbo C. This is evident in Turbo C. If you're going to compile your code, it will produce the .obj file of your source code. And then next is we have the source code. It can be for C, and then we have for C++, and then we have for Java, we have for Pascal, we have .asm for assembly language programming, and then .a is for static libraries. So these are the source code in various languages. So of course, these are not limited to this one, because there are other programming languages that exist, such as, for example, Python, that's .py. So it depends upon the programming languages that you are using. So this is not limited just for C, Java, Pascal, assembly language programming. Next is we have the batch. So it is in that bat or sh or shell. So commands to the command interpreter. And then for text file type, of course, the file name extension is .txt or .doc, or for more modern is .docx. So the function is textual data or documents. And then for word processors, so .wp is this is the file type of Corel WordPerfect. This is specific. It's also of course a word processor file type. So the .tex, there are other file type such as this. And then we also have the .rtf, which is rich text format. And then of course, just the same with text, .doc or .docx. So various word processor formats. And then for library, so we have .lib, of course, it's easier to distinguish. And then A, just the same with the source code, static library. .so is shared object. This is specifically in Linux. And then we have .dll for dynamic link library. So this is typically with the applications as of today. So libraries of routines for programmers. And then for print or view file type, we have .ps. So .pdf or .jpg. So .ps may be in, of course, in Photoshop. And then PDF, of course, is Adobe Acrobat Reader. Portable document file, and .jpg is an image file. So ASCII or binary file in a format for printing or viewing. So again, this is not limited to .jpg, because there are also other image or picture file types such as .gif, .png, .bmp, .tiff. So we have many file types for images. And then we have archive. We have, of course, .arc, .zip, and .tar. So tar, it came from the name with tape archive files. So that's why it's called tar. So related files group into one file, sometimes compressed for archiving or storage. And then for multimedia, we have .mpeg, .mov, or movie, .rm. RM is for real media files. And then, of course, for music, specifically music, this is .mp3 and then .avi. So binary file containing audio or audiovisual information. But again, this is not limited to this one because we know other file types such as .mkv or .ogg, what other files? We have MPG. So there are many files that is, for example, for audio or for videos. So this is file type multimedia. So music and movies or videos are categorized as multimedia file type. Okay, next is we have the file structure. So file structure can be none or a sequence of words or bytes. And then it can also be a simple record structure. So it can be composed of lines, fixed length, and variable length. And it can be complex structure such as formatted document or relocatable load file, and then can simulate last two with first method by inserting appropriate control characters. So who decides that is we have the operating system and we have a program. So again, let's illustrate with a formatted document. So let's go again with our folder. Okay, we have this, if you are familiar with the picture, so of course if I'm going to click it, so the default program here is, of course, again, let's wait to load the picture in memory. Okay, so if you can remember, this is in our one of the previous lesson, past lesson. So, of course, if I'm going to click it, so again, let's click the right click it. Again, please wait for the for loading again. Sorry for the speed. Okay, counting. Okay. Okay. Okay, so let's click properties. So, okay. So this is our default um, application or program to open that JPG. And as I've told you with the file pointer location, so this is the file pointer location. Okay. Okay, so since we've opened it is opened with Photos applications. What if we're going to open it in a notepad? Okay, so what if you want to? Okay, just be curious. What will be the... Okay, actually, notepad can open anything. So, this is the Amdahl's Law P1.jpg. Different from what we have seen here, it's actually a picture. But of course, if you're going to put it in a notepad, this incorrigible characters here. So for us, we do not understand this, but if it is going to be processed by the computer, so actually this is the content of the picture file. So for us, if you're going to open it with the right application, we can see the picture. But of course, if you're going to open it in an application that is not meant to open that particular file of type of file, you can see um, these characters. So please don't edit anything, because if you will edit even the smallest character, made your file corrupted. So this is what I've been telling. So for formatted documents, they have specific applications to open with. You cannot open it to any other file. Okay. So I have another illustration here for the file pointer before I forget. So for file pointers, for example, we have programs here. Okay. So for example, we have this one, Arduino. Okay, this Arduino here is what? Okay, this Arduino here is actually a shortcut. Okay? So, this actually, of course, if you're going to create a shortcut, it is really not the actual file, but it's only a pointer to that file that you want to open. So, where's the original Arduino application is located? So, this is the path name. So, it is in the Start Menu program. So, again, please wait for the context menu to load. Okay, let's wait for it. I'm really very embarrassed with my computer because even the context menu it takes a while to appear. Okay, let's count. Okay, thank you very much. Okay, properties. So as you can see, the properties for an actual file is different with a shortcut file or a pointer because you can see here that this is the location of the actual um, file that you are opening. It's not really the Arduino here. The ones here, it's just a shortcut. It's not the actual .exe file. So, again, okay. So, why does Windows do this, the shortcut files? So that, of course, users will not go to the actual folder because the actual folder is in very it's not very sensitive. It's just that since it is in the inside drive C, which is the system file C program files x86. If you are just a user who the do not know that you cannot just modify anything inside that folder. So let's see, we can open, of course. If you're going to open it, if you do not know what you're doing, just leave it be. Again, better safe than sorry. So this is the actual Arduino.exe that you are always, for example, if you want to open the program Arduino, this will be the program or application to be executed specifically. And of course, since this is under Windows and then program files x86, so do not delete anything, modify anything because it is considered as a system file so that your installation of the application, example for Arduino, will not be corrupted. So let's close this again. So this is the what I've been telling you about file pointers, the shortcut links for the files. Okay, let's close it now. And let's return with our lesson. Okay. So again, with opening of the files, the one who decides that is the operating system in the program. So what if there is an instance that you installed different applications but can open that same particular file type? So it's up to you as a user if you want, for example, to open it in this application or program. So, for example, that image, um, of course, the default is photos applications. But if you are an editor, you want always to edit first your pictures. You can change it into Adobe Photoshop. So, again, let's return. Let's wait again. Okay. Ah, let's wait again for our context menu to appear. I should have already demonstrated it, right? Okay. Okay, let's wait. Maybe you're thinking I should buy a new one, right? But of course, it's still functional. It still meets my expectations. Okay. Okay, properties. Okay, so it opens with photos. Actually, you can change it with, of course, this is the recommended. So you can open it by using Adobe Photoshop, Google Chrome, or Photomaster. Of course, if it's in Notepad, the problem is you're not going to appreciate it, or in Paint. Okay, as long as it is related to image files. So opening image files is just okay. But for me, as the user, I only want to view the photos. It's not that I want to always edit it first. So the default app is the Photos application. So again, you can change it in here and select the appropriate application. But from the list, if you still can't find what you're looking for, you can click More Apps. Okay. Okay. You can open it in the media player. But then again, you have to open it with an appropriate application program. So since I don't want to change anything, so let it be as the default is the Photos application. Okay, let's continue. Okay, next is we have the sequential access file. So for this one, for sequential access, so imagine it as a tape drive. So you're already here in this position, so you can rewind, go back, and for going to the end, it's either read or write. Okay, for access methods, for file system, we have sequential access. So these are the typical um, commands. We have read next, write next, and then reset, and then no read after last write or rewrite. For direct access, so the file is fixed length logical records. Okay, the typical commands are read n, write n, position to n, and then just with sequential access, read next, write next, and rewrite n. N is equal to relative block number. So relative block numbers allow OS to decide where the file should be placed. So see allocation problem in the next chapter, in chapter 14. Okay, so simulation of sequential access on direct access file. So for sequential access, so reset, the command for direct access is CP is equal to 0 because you're going to reset. And then for read next, so the corresponding direct access is read CP, and then CP is equal to CP plus 1. And then for the write next sequential access, its corresponding direct access is write CP and then update CP. So CP is equal to CP plus 1. You're going to add one value to CP. Okay, next is we have other access methods. So can be built on top of base methods. So generally involve creation of an index for the file. So keep index in memory for fast determination of location of data to be operated on. So consider UPC code plus a record of data about that item. So if it is too large, index in memory of the index and then on disk. And then IBM has Index Sequential Access Method or ISAM. So small master index points to disk blocks of secondary index, and then file kept sorted on a defined key, and all done by the operating system. And then the VMS operating system, this is another, of course, operating system, provides index and relative files as another example. So for example of of index and relative files, so the index file contains list, and then for example this particular file, so in the relative file this contains the whole um, contents of this example Smith. You're looking for the with the last name Smith, so it contains all the information about John Smith in the relative file. So for using index, it's faster because this is listed. And if you're going to look for a file instead in the relative file, because of course it will take a longer time to look for, because relative file is larger than the index file, because index file is just a list. Okay, next is we have the directory structure. So a collection of nodes containing information about all files. So this is an illustration of how this a directory looks like. as a simple as this one. So we have directories, so more like folders, and then for every directory, there are files inside. So both the directory structure and the files reside on disk. Of course, if you're going to create a directory, the directory should have a content. So it doesn't look good because of course you're going to create a directory, then there's no content, it's empty. For me, if it is a user created directory, it's better for you to delete it, because what's the use of creating a directory for that if you're not going to put a file inside? So next is we have the disk structure. So disk can be subdivided into partitions. So if you're going to format your hard drive, automatically it will subdivide your disk into partitions. But of course, it depends upon if you want to use the whole disk as a one. It's like a one whole volume or drive, or if you want to put it like, for example, partition it's like a house. You want to partition your living room, your bedroom, your kitchen. So that is like the idea here with partitions. So disks or partitions can be RAID protected against failure. So we already have a lesson of RAID, or redundant array of independent or inexpensive disks. And then disk or partition can be used raw. So raw without a file system, or formatted with a file system. So most basically for Windows, so it is requirement to format the partition for it to be usable. And then partitions also known as mini disks or slices, and an entity containing file system known as a volume. So each volume containing file system also tracks that file system's information in device directory or volume table of contents. As well as general purpose file systems, there are many special purpose file systems, frequently all within the same operating system or computer. Okay, a typical file system organization. So, the typical in Windows is we have these whole disks, and then you want to divide your disk into two partitions. So, that is the common setup in a Windows system. But there are others that, for example, so this whole partition is it it needs two disks. So I'm really actually very not familiar with this one. I'm more familiar with this setup. So why? So again, let's go back with with my file. So let's go to this PC. So as you can see, I have, except for the DVD drive, of course, it's a different drive. So you can see here as three drives. Actually, when computer was first, of course, the old computers, partition is not possible at that time. So if you're going to see your drive with old computers, you can only see one drive. So for that time, for old computers, if you see one drive, means you have, if you see one drive C here, meaning you really have one drive in your computer system, a physical hard drive. But now, because of partition, so what if your old computer has two drives? So it means that it's not a partition. It really does mean that your computer system has two physical hard drives. But because of partitions, as users, we can see that we can have as many drives as you want because of the partitioning of the whole drive. So for this one, we have three drives here. So we have for Windows, and then this is a system partition actually. Actually, it's your choice. Actually, the content of this one is for the backup of the drivers of this laptop, of course, the brand. But of course, as I've told you, you can actually um remove this partition, and this 25 gig can be added to the other partition. So this partition, so what I've been doing, so it's always like this. So we have a different partition for where the Windows or the operating system is installed, and then this partition is used for data. So the advantage of this one is, if your hard drive does not have any partition and you only stored your files, your documents, in pictures and videos, and your Windows, for example, got corrupted, or it has an error, or it has crashed, or just say that the the Windows installation becomes unusable, so as your documents. So that's why, if I always do it. For example, if there is only one partition for Windows, I always um, divide it into two, the partition, so that the other half will be used for data, and of course all the applications are in the Windows drive, where in the drive where Windows is installed, which is in drive C. But this one, so why did I remove this partition and include it in my drive for data? It's just too small, so maybe I can deal with it. So it's just for fail-safe operation, so that if ever, of course, the laptops nowadays does not have an installation of Windows anymore, as with old computers. So the only thing that you can do to revive your old operating system, or if the installation becomes unusable or corrupted, is you have to back up your Windows installation by using the backup, and of course reinstall all of the device drivers for this computer system. So again, you can see here three partitions, three drives, but it does not necessarily mean here that it has three physical drives. No, it only has one disk drive, but with three partitions. So this is the setup here. So for this one, I don't know how is it possible for two disk and then there's only one directory of or file system for that. Okay, so let's return again with our presentation. So again, this first is the most commonly used for typical file system organization. Okay, next is we have types of file systems. So we mostly talk of general purpose file systems, but systems frequently have many file systems. Some are general and some are special purpose. So consider Solaris has, so it has a TMPFS. This is memory-based volatile file system for fast temporary I/O. So that's called TMPFS. We also have OBJFS, interface into kernel memory to get kernel symbols for debugging. And then we have CTFS, contract file system for managing daemons. So LOFS, so loopback file system allows one FS to be accessed in place of another. And then we also have another, the PROC-FS, kernel interface to process structures. And we have the UFS-ZFS, general purpose file system. For Solaris, it uses different file systems depending on the operations of or the applications. So that's an example for Solaris. So we're not really very familiar, of course, because we are more familiar with other operating systems such as Windows. Okay, next is operations performed on directory. So you can search for a file. So again, how to search for a file? So it's convenient for Windows because they already have this search box. So you can search anything here. You just type anything. So if you're going to search for any text file, you can have, this is a Windows, rather DOS. This asterisk means disregarding of the file name. Okay, disregarding of the file name, you're looking for file type .txt. So that you can see here that it really is looking for any file types that is .txt, disregarding its file name. So what if you're going to use asterisk dot asterisk? It just means that if that's asterisk dot asterisk, you're going to search for all files. Actually, it's very cumbersome. You're searching for all files. So this of course will be more usable if you knew the file name and of course the file type. I just illustrated to you the usage of asterisk. Asterisk disregarding of the file name, and then if you put asterisk dot asterisk, this you're searching for files disregarding of the file name and file type. So it means it will search for all documents with all file types that is inside your computer system. So let's just stop it, the search. But if you want it to be more specific, you can go to a specific folder. So that's why, of course, you can only search for that drive, because here, of course, the smaller the it's like searching for a room. So if you really know where to search your files in that particular folder, it's better than to search, for example, with this one in this PC, because it will search for drive C, drive D, and drive F. Okay. So you can also, of course, you've already have an experience for creating a file. Of course, user created files such as Word documents, slideshow presentation, Excel file, or any other files that you are required to do. And then you know how to delete a file. Okay, it's just right click or then delete, or just click on the file and then press the delete button on the keyboard. And then, of course, list a directory. I've already shown you in our previous lessons by using the command prompt how to list directory. In the prompt, dir/w, okay, /p, or so that's an example. And then to rename a file, so you can, as you can remember, you can rename a file in the properties as I've in the previous slides, because you can change it there, or you can right click and then rename a file. And then of course you can also traverse the file system. You are already doing the traversing the file system if you're searching for that particular file. Okay, next is we have directory organization. So the directory is organized logically to obtain, first is the efficiency, locating a file quickly, and then also the naming, convenient to users. So two users can have the same name for different files. It is true as long as they are in different location. And then the same file can have several different names, as because if you want 6 copies and you want to put version 1, version 2, version 3, version N, so that same file can have several different names. And then we also have grouping, so logical grouping of files by properties such as all Java programs or all games. So actually in my example, we have this grouping. Okay, let's go with our folder. So, okay, so again, with our, as you can see, this is already grouped. For me, it's better to search by, we have this one. You can view it as group, as, for example, none. Okay, if it is none, and then view by, for example, by name. Okay. For me, I don't know if it works for you. Maybe it depends upon the person. Of course, this is in alphabetical order, but for me, it's very difficult that it is arranged in this fashion. So I always do is, you can group by type. For me, it's easier because if I already knew the file type, I'll just going to go, for example, oh, I know it's a PDF file, so I'll just need to search for this, and it's already arranged. These are all grouped for PDF files. So it is click anywhere, then group by type. You can do it date by date modified if you want to. Specifically, if you can remember that you've modified this file on this date. So it depends upon your preference. But for me, it really works for me is the grouping of the same file type. So you can change it the way you want if you have your own computer system. So again, let's go back with our presentation. Okay. Okay, so for the structure, there is a single level directory. So a single directory for all users. So we have an example. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Example here is we have 9 directories or folders and they have their own files. So since this is a single level directory, so one folder and then file. So we can encounter for single level directory, we have the naming problem because why? So files must have unique names, of course. And then the grouping problem, you can't create folders for this. For example, you have files and you want to group it to this type of file, or it depends upon your preferences of whether what is the name or what is the category of that file. So you can't create another folder inside the directory because it's a single level directory. Okay, next is we have a two-level directory. So we have a master file directory. So it's named after the users. And then they have their own set of directories. And we have the files. So by means of two-level directory, there is already a path name. And it is also possible that it can have the same file name for different users, of course, because it's a different directory. So for this example, user 1 has a directory also with user 2, with user 3, and user 4. And this uh, directory does not mean for them that they have the same contents. No, it depends upon the user's preference of what files he or she can put in that A directory or folder. So it is efficient for searching and still it has no grouping capability. Okay, next is we have the tree structured directories. Actually, this is the modern day structure of directories, specifically in Windows. So, for example, this is the root directory. You can have as many nested directories or folders inside. So, for example, this is spell root directory, and then we have mail, and then mail has PRT and it has another directory for first and then the file. But also it can be a combination aside that there is a folder, there is also a file. So that is the tree structured directory. So for tree structured directories, of course, we have efficient searching and we already have the grouping capability. So current directory or working directory. So CD, as you can remember with the command prompt or the Windows shell. So this is different because CD here in Linux is current directory. For Windows, it means change directory. So this only means that it is in the current directory, or we have another command for type list. Okay, we have here, so for this three structured directories, we have absolute or relative path name. For absolute, meaning its path name starts with the root directory, while the relative path name, it is the current directory. So creating a file is done in current directory, of course. So even in our directories, that is, for example, we are using Windows, if you want to create a file, it will be done in the current, it will always be done inside that directory or the folder. Okay, how to delete a file? So we have rm. So this is Linux. This is very different with command shell. So the command is rm and then file name, and then creating a subdirectory is done in current directory. So mkdir. So this is creating a directory. For Windows, it's md, make directory. So if in current directory /mail, mkdir count. So mail, and then it added new directory count. Then deleting mail, deleting the entire subtree rooted by mail. Okay, let's create a an example. So how are we going to create a file? Let's open again our file explorer for you just to illustrate. And then we're going to illustrate it in Windows. Again, let's wait again. I'm really very sorry for the fast response of my computer. Okay, do you think I need to buy a new one? I think so, but I still don't have money to buy. So I'm just going to stick with it for a little while. Ah, okay. Thank you again. Okay, let's go with the desktop and then let's create a file. Okay, we have just a simple text file. So new, okay, text document. So again, test.txt. And then let's open our command prompt. Okay, so you just want to locate our di to locate desktop dir/w/p again to list the directory. So of course, desktop is here. So cd desktop. Okay, let's again list the contents of this directory. So as you can see, it is already here, the test.txt. So what we want to do is what? We've already created a file. So of course, you can see that when I created the file, it is really inside that folder or directory. You cannot create a file, intended file, if you're not in that directory. I think it's not, I don't know if it's really possible, but for me, in my opinion, it's not possible. You have to be in that directory to create that file. So if you want to delete a file, for this command, for Linux, it's rm. But as you can see, we have, okay, so we want to delete test.txt. So the command here is del and then test.txt. Okay, so it has no response. There's no error. So let's just see if the delete is successful. So again, dir/w/p. Okay, there is no test.txt. So it means I've really deleted the file. So for Windows, the command is del. Okay. Then creating a new subdirectory is done in the current directory again, of course. So what if I want to create a new directory? So let's just follow the example. For example, mail. Okay. So for creating our directories, we have md, then mail. Okay, let's check dir. Let's just not type it. dir/w/p. Just click the up arrow because it lists your previous commands that you have typed. You don't need to type it anymore. Okay, so we already have mail. And then it also wants to have create a directory for the name is count. But of course, if you want to create a directory, you have to go inside. It's like clicking the folder and you'll be inside the folder. For again, for this command prompt, you want to go inside mail. So you have to cd. So again, so for Linux, cd means current directory. But for Windows, cd means change directory, then mail. So as you can see with the prompt, you're already inside the folder mail. And then you want to create again another directory. So dir/dob. Okay, let's not type it anymore. Up arrow. Okay, so you can see here that you already have the folder count inside the folder mail, a nested folder. So, can we delete mail? Deleting the entire subtree routed by mail. So, for Linux, it's possible that if you're going to delete mail, you can delete also its child directories or subdirectories. So, let's just go back with desktop. Okay, cd point, meaning you exited that current directory, then again, okay, let's delete. So, deleting directory here is by means of rd mail. Okay, so for Windows, for command, actually in DOS, this is really actually not possible. If you're going to delete a directory here inside a command prompt or in DOS previously, make sure that the directory is not empty. But of course, if you're going to use our File Explorer in Windows, just click the folder, disregarding if it has a contents or it has no contents, just right click and then delete, it will be deleted. But for here, for Windows Shell, command prompt, Windows Shell, or previous the DOS disk operating systems, it will always require that for you to delete that particular folder or directory is make sure that it is empty. So you can't delete mail directory. So again, you have to go inside, okay, inside mail, okay, and then since count here, as you can remember, okay, you can remember it does not have any contents, okay, just to make sure, okay, dir slash w slash dash slash w slash p, it really does not have any content. So you can't delete this folder count because you're inside it, so you have to go back. You have to be inside mail and then rd count. Okay, dir slash w slash p. So count directory is not already, it's already deleted, so it's already safe to delete mail directory or folder. So rd mail, okay, so dir slash w slash p. So is there any mail? Okay, does not have any mail directory inside desktop. Okay, so this is how it's done in command prompt. So let's exit. Okay, then let's return. So again, to delete a folder for File Explorer, it's easy. Just right click and then delete. But if you're inside the command shell, you have to make sure that the directory is empty before you can delete it. Okay, next is we have Acyclic-Graph directories. So Acyclic-Graph directories have shared directories, subdirectories, and files. Okay, so this is an example for, we have for a root directory, then dict and spell. So as you can see, list for dict, it has in the folder directory W and then list. And then for spell, it is words and then list. So this is what we call acyclic graph directories because these two directories share the same directory. Okay, so the problem here is two different names, so aliasing as you can already see. So for dict, the directory here is W, and then for spell, it is words. But still, they're pointing to the same directory. They're sharing the same directory. So what if dict deletes list? Okay, so the problem here now, let's go back. What if the user dict deletes list? Not this list, but this list, because these are shared. So if dict deletes this, so where does words be pointing to? So that's why there is a dangling pointer. So the solution is to use back pointers so we can delete all pointers. So variable size records a problem. And then back pointers using a daisy chain organization. And then we also have the entry hold count solution. What is entry hold count solution? A count of the number of references. It is typically used in Unix for hard links. So next is we have new directory entry type. So it's either we have link or another name or pointer to an existing file, or resolve the link, follow pointer to locate the file. So as you can already see, to resolve the link, for example, your shortcut in your start menu programs, it does not look like the icon. For example, okay, again, let's just illustrate. Example, you notice that your shortcut here becomes a blank file, meaning the target directory or the target application is not correct. Actually, you can change the location so that it can be corrected. There's also that is the solution for this one. So that is the resolve the link. Follow pointer to locate the file. You can change the target directory for those shortcut links. Okay, next is we have the general graph directory. So again, we have the root directory which contains users AVI, TC, and GIM. And then this is the general graph because for AVI, so the directory of AVI, book, and GIM's book directory, it has a pointer for AVI, and then it has also a link inside the directory of book. So that is the general graph directory. So for how do we guarantee no cycles? So allow only links to file, not subdirectories. So for this example, for ABI folder, there is also a shortcut here. So that is okay because it says here to guarantee no cycles, allow only links to file, not subdirectories. And then of course we have garbage collection. So to determine whether the last reference has been deleted and the disk space can be reallocated. And then every time a new link is added, use a cycle detection algorithm to determine whether it is okay. Okay, next is we have file system mounting. So a file system must be mounted before it can be accessed. So an unmounted file system with the letter B, so is mounted at a mount point. Okay, so with this one, this letter A is mounted because has the root directory, but for B, it is not mounted. So that's the difference between the two. So mounting, it's like in the case of our computer example, our flash drives. So since our flash drives are drive storage devices, so if you're going to connect it with our computer, and since it's a flash drive, it will be automatically mounted by the computer since it is registered as a device drive in the device driver that it has a storage device. So for you to use it, it should be mounted. So that's why if you're going to use your flash drives, you can see that it will appear in the alongside with the drives. So it is automatically mounted once it is detected. And also for Windows, so our hard drives are auto-mounted once the computer has started. So you don't have to worry to mount it all by yourself or manually because Windows is the one who's responsible for mounting all the existing drives. So for the case of Android phones, so if your smartphones has the capability for OTG. So if you're going just to insert the OTG cable and then connect the flash drive. So as you can see with the storage, if it also automatically mounts if it is detected that the connected in the OTG cable is a storage device. And then you can see in the system that you can unmount the storage device. So what's the use of unmounting? So for flash drives connected in the PC, so it's like properly ejecting. So as you can see, let's have an example. Okay, I've inserted a flash drive. Okay, so let's see if it is detected. Oh, there's a problem with my hard drive. Well, anyway, so this is my hard drive. So it is automatically mounted by our operating system because it is detected as a storage device. So it is mounted. So to unmount it, so the term here in our computer is what? Eject for computer. But for Android smartphones, in the system, in the storage, is we have unmount storage device. They have just this a different term for it, unmount and then eject, but the process is just the same. You just have to properly eject or remove your device. So it's really a really good practice that if you're going to disconnect hard flash drives, you must properly eject it or properly unmount it, because there are cases that if you do not unmount it properly or eject it properly, the time again that you're going to insert the device, it becomes unusable. So better safe than sorry. Just follow the protocol that to eject your removable drives properly. So if you have here eject, or actually it's also in here, you can eject. So this way, you can also protect your files and of course your removable drives too. So it's better to properly eject or properly unmount, specifically for smartphones. Okay, so that is the concept of file system mounting. So the mount point is this one, so the root directory. So it means that it is mounted on your system. And then for Windows, you can actually know if your drive is mounted because you can see the drives in the list in this PC, for example. Okay, next is we have file sharing. So sharing of files on multi-user systems is desirable. So sharing may be done through a protection scheme. On distributed systems, files may be shared across a network. So a network file system, or NFS, is a common distributed file sharing method. If multi-user system, they can use user IDs to identify users, allowing permissions and protections to be per user. And then group IDs allow users to be in groups, permitting group access rights. And then you can be an owner of a file or directory or group of a file or directory. This can be shared. So for file sharing in remote file systems, so uses networking to allow file systems access between systems, manually via programs like FTP, automatically seamlessly using distributed file systems, and semi-automatically via the World Wide Web. And then the client-server model allows clients to mount remote file systems from servers. Server can serve multiple clients. Client and user on client identification is insecure or complicated. So again, NFS is a standard Unix client server file sharing protocol, and CIFS, which is common internet file system. So the Windows Network File System, now used on many systems, the CIFS. It is the standard Windows protocol. So standard operating system file calls are translated into remote calls. So distributed information systems or distributed naming services such as LDAP. So LDAP is Lightweight Directory Access Protocol, or DNS. So DNS is Domain Name Service or Domain Name System. And then NIS is Network Information Service. And Active Directory implement unified access to information needed for remote computing. So what are the failure modes for file sharing? So all file systems have failure modes. So for example, corruption of directory structures and other non-user data called the metadata. So remote file systems add new failure modes due to network failure or server failure. So recovery from failure can involve state information about status of each remote request. So state information, so in remote file systems, the set of information pertaining to connections and ongoing file operations such as which files are open. So for stateless protocols such as NFS version 3, include all information in each request, allowing easy recovery but less security. For stateless protocols, so in a remote file system, a protocol in which state need not be maintained for proper operation. So that is why it is called stateless protocol. Okay, next is for consistency semantics for file sharing. So specify how multiple users are to access a shared file simultaneously. So similar to Chapter 5's process synchronization algorithm. So it tends to be less complex due to disk I/O and network latency for remote file system. And then there is a file system which is called Andrew File System, or AFS, implemented complex remote file sharing semantics. And then Unix file system, or UFS, implements writes to an open file visible immediately to other users of the same open file, sharing file pointer to allow multiple users to read and write concurrently. So for Andrew file system, it has session semantics, writes only visible to sessions starting after the file is closed. So next is we have protection. So the file owner or creator should be able to control what can be done and by whom. So the types of access are read, write, execute, append. So append is write new information at the end of the file, and then delete and list. So next is we have access lists and groups. So the typical modes of access is read, write, and execute. So for Unix and Linux, the three classes of users are, so owner access. So the code is 7. So this is for read, write, and then X is for execute. So why it is 7? So owner can read, it can also write because it's 1, and then it can also execute. Why it is 7? Because as you can remember with binary, okay, let's have, this is 4, okay, then 2, and then 1. Let's add those that are 1. 4 plus 2 plus 1. 4 plus 2, 6 plus 1 is 7. So their code for owner access is 7 based on the binary. Okay, so that's why it's code 7. Okay, next is group access is code 6. Why it is code 6? Group access can read and write, but it cannot execute. So 6, it's because 4 plus 2 is equal to 6. And then public access is only, it's code 1. Why? Public access, it cannot read, it cannot write, but it can execute. So that's why its code is 1. So ask manager to create a group or unique name, say G, and add some users to the group. For a particular file, so say game or subdirectory, define an appropriate access. So to define, so mode 761, so meaning can be a owner, group, or public, and then the subdirectory is game. So attach a group to a file, group G, and then game. So this again, the commands here is not Windows but more of Unix or Linux. So this is the Windows 7 access control list management. But again, you can see that in our okay, so just discard my okay, let's again return. So again, sorry for the delay, for the context menu again. Okay, let's return to our, okay, let's wait again for the context menu to appear. Okay, counting. Okay, thank you again. Okay, properties, then security. Actually, it's in security. So, the group or usernames that can access this file, we have authenticated users. So, for authenticated users, so this ID, so the ones in the presentation are the common access modes. But here in Windows, we have full control, modify, read and execute, read, write, and special permissions. So if you're an authenticated user, you can modify the file, you can read and execute, read and write. So because that's, we have allow. Then there's no marks for deny. Then for system, so if the user is a system, it has full control. So that's the difference with authenticated user from system, because it does not have any full control. And then the only thing is we have there's no check for special permissions. So for administrator, so just the same with system. If you knew the username and password of this computer system. And then for users, So if you're a public user, so you have only read and execute and read, or any users identified inside this folder. So you can see different users, they have different access modes. Okay. Okay, for this example, so if you're a guest, it is all deny. You just can view the file. Okay, this is an example of Unix directory listing. So of course, it's a little bit different with Windows because of course we're familiar with the Windows system. So it's just show that this is the directory listing for Unix. So okay, so I this is the end for our chapter, for our lesson. So I hope that you've learned many things about file systems. So this file system makes the different OSs unique to each other. So if you do have any questions, please feel free to comment below, and please don't forget to subscribe to my YouTube channel. So again, thank you very much. Good day and stay safe.